Hello, how are you all doing today? Excited for more talks? Woohoo. How many of you are Angular developers in here? Okay, just checking. I just came from like a back-end conference and I'm one of the standout front-end people, so it's always interesting. But today we're going to be talking about Angular magic with Angular Schematics. Before we get started, you might have determined by my accent that I am not from here. My name is Jennifer Wadella. I come from Kansas City in the middle of the United States. If you want to follow me on Twitter until it crashes, you can follow me at OMG it's Sveti. I'm the VP of front-end engineering at a JavaScript consulting company called Bitovi. So I spend my days consulting, seeing clients do a lot of things they probably shouldn't be doing, and see a lot of the situations they run into adopting different tools and technologies, and me and my team come in and try and help them the best we can. And that's actually where this talk comes from, is one of those horror stories one of my clients have run into before. Does anybody listen to the Angular Plus Show podcast? Nice, okay, all right, so you know who I am. So it's the official Angular podcast of NGConf, which is the premier Angular conference over in the States. But we do a lot of different episodes about everything from Angular to Angular adjacent. So that is a good listen if you're looking for some additional content in the Angular space, as well as I am also an Angular GDE. Okay, so wow, this is really slow and laggy. Okay, so we have a couple goals for this talk while we're talking about Angular schematics. Number one is obviously to learn about them, what they are. Number two is I want to show you how to actually create your own schematics. And then hopefully you're going to delight in automation, all the things you can automate and all the time that you will save by having this newly harnessed Angular magic power. So when we talk about Angular schematics, this is the definition from Angular. A schematic is a template-based code generator that supports complex logic. It is a set of instructions for transforming a software project by generating or modifying code. Hopefully this concept feels a little familiar to you because as an Angular developer, you've used schematics every day in your development process. Every time you run ng-new, that is a schematic under the hood that the Angular team has built. That's what's generating all your files. That's what's giving you those different prompts in the console. Do you want to include routing? Which CSS framework do you want to do? So all that's there. If you've ever used ng-generate to generate, a new service file or a new component, that's a schematic as well that's taking that input from you of what you want to create, what you want to name it, and then scaffolding all that code out for you. And then there's also an ng-update command that gives you a little update magic. So I want to talk through a real-world example, and this is definitely something that happens fairly commonly in the wild. Not as much anymore, but you might be using this third-party library. They do some sort of massive upgrade, and there's some sort of breaking change. And so you might have to go through your code base, and we're talking about changing, hundreds, maybe thousands of lines of code. So in this real world example, we had a team, they were using a library. I'll go ahead and name it. It was NGRX forms. Does anybody? All right, you might know where I'm going with this then. So NGRX forms to kind of bridge and handle state between NGRX and that forms. And they had this one method, and that method took 2 parameters. And in one of their versions, they swapped those parameters. No idea why, but so they had sprints and sprints and sprints that they dedicated to basically grooming through their code and switching these 2 damn parameters so they were able to upgrade this library. It was absolutely ridiculous. And that was the approach they took. They did this manual update, and so that's what they had to sit there and do, is just comb through files and switch the parameters, and we all really love that kind of repetitive work, don't we? Okay. So how could we have used Angular schematics to solve this situation? How could we have saved ourselves a couple sprints, a lot of heartache, a lot of drama? Well, we could learn to harness the magic of creating our own Angular schematics, and that's what we're going to do for the rest of this time. Okay, so key concepts with schematics, we have the idea of a virtual file system. So this represents the files that we're going to be making changes to or possibly creating. We've got transformation, so if we are going to be changing the contents of those files, that's what a transformation is. We also have rules that we are going to define for how these are going to be applied. We have schematic prompts, so as we're taking input for a user, that could be anything from what something's going to be named to, would you like this to be a red component or a blue component? That's a very abstract concept, but we have schematic prompts. And then finally, we have AST, the abstract structure tree, that is a complicated beast and is probably the scariest part of dealing with schematics. So when we look at this virtual file system, this is represented by a tree. And so it's very similar to, you've got your side nav in your editor, maybe you open up your folder structure and you kind of drill down. It's a set of files that already exist, and then there's also a staging area. So we're going to have our existing files, we're going to stage whatever we're making changes to. That could be modifications from our original one, that could be new files that we're creating. So what's happening is when we're making our modifications, we're not actually changing those files. We're doing that in a staging area, and then that's the actual change that happens. So this is what the interface looks like for a tree. This is not super well documented by the Angular team, so sometimes you do have to get down a little bit in the weeds. This is why TypeScript is so amazing. Y'all know this. It's very easy to navigate and read about different properties and options that might not be documented. But this is what that interface looks like for the different properties and methods that are available. So if it's not in the documentation, just remember you can go view the source code to figure out anything you need here. Okay, so we've got a couple basic transformations. We can do a creation one. Again, this is what you're seeing anytime you use the ng-generate command, for instance. We also have a rename one. This is pretty cool. I don't know if you've ever walked into a project, maybe some back-end developers have started it and all the files are in CSS. And you're like, oh, you pleb, how dare you not use some sort of compiling language? Well, you could actually use a rewrite schematic to rewrite all those file names to at least .scss or whatever you want to do, and then start to, over time, change those, and you'll have your compilation ready to go. So there's some powerful stuff we can do just through renaming. We can also overwrite, which is completely overwriting the contents of our files, and we can delete as well. So plenty of options there. We've got rules. These are the changes that we wish to make to our project. Our rule interface is going to look like this. I'm not going to go super in depth to it. I haven't had to really dive in and understand that much from the rule interface to get what I needed done. And then we have our different schematic prompts. So prompts are letting us accept input from the user, and we've got 3 different types. We've got a confirmation. It's going to be your basic yes or no. We've got a default input that's going to take some sort of text from user, or maybe we're going to present a list. So that list example, again, if you run ng-generate, or ng-new for a new project, seeing those lists of different CSS compiler options. That's an example of the list. To create a prompt schema, it's going to look something like this, where we are doing a prompt that is a basically Boolean prompt. Would you like this in response to color, yes or no? For this use color example, the name was just a general input one. So when we start to configure the input prompts inside of our schematic, this is what that's going to look like. Abstract syntax tree is our representation of the source code. This stuff gets squirrely. And you have kind of 2 different options with schematics. You could regex your little heart out. It's a pain in the butt. Or you could try and use this. And basically, this gives you that visual representation of your code. There are a couple of different libraries that make this a lot easier to use. I'm not sure if you're familiar with Craig Spence, but he's written this library called tsquery that I use in this example to basically take the file, code out of my file, transform it into the abstract tree syntax, and it's easier for me to kind of look at functions and figure out what's going on. There are a couple great visualization tools I have linked in here that are very, very helpful for this. Okay, so here's our example of our breaking change in a third-party library where we have some sort of breaking function. That original first parameter was a string, the second parameter was a number, and it does something. This is very basic for our example. The new function they have put out, they have now swapped those parameters, so of course it's not doing what it's supposed to. Our compiler is yelling at us. Every file is red squigglies. Everything sucks. So the first step for schematics is to go ahead and run the install command to install these globally. If you're taking screenshots of these, by the way, or taking photos, I do have these slides linked at the end, so don't panic. This is a lightning talk. I've got everything there for you. So once we have our schematics installed globally, we can go ahead and run this schematics command, schematics blank. Blank is just going to generate us a blank schematic -- name and pass in the parameter of whatever you want your schematic to be named. In this case, mine is called fixit. What this is going to do is it's going to create a base minimal schematic. This is the default rule and structure that is provided. So the things that we want our schematic to do in this use case is we want it to look through all the application files to find instances of the altered function. We want to get the content of those affected files. We want to swap the parameters of those affected functions. And then finally, we want to go ahead and overwrite all those affected files with the new content, creating the parameter swap. So remember, I mentioned like we have our original files, then we have the staging. That's going to happen in the staging, and then the overwrite happens. Okay, so to do this, our schematic is going to look something like this. And again, like the hardest part, in my opinion, of dealing with schematics is just navigating some of these code changes. And so this code is a quick and dirty way to basically find all the functions with an instance of breaking function, which is what that function is named, and then making some assumptions and swapping those parameters. So the source code is there and available for you, but that's not important for the purpose of this demo. When you have built your schematic, you need to remember to build it. This trolls me every time because I'm like, why isn't it working? Oh, well, Jennifer, you have to rebuild it every time. Duh. So you can just navigate into the directory of the schematic that you have created, which is going to have been created at the root level of your Angular project, and then run npm run build. So every time you make a change, rerun the build. In order to run the schematic inside of your project, you can go ahead and just type schematics, the path to your schematic, and whatever it's called. These, if you run it by default, just that schematics fixit, it's going to do a dry run by default. That means it's going to preview you what your changes are going to look like and then show you it. So you can see the changes, make sure everything looks accurate, and then when you change that dry run flag to be false, then it will actually do the full change for you. The tricky thing that is not well documented when we're taking this approach is you do have to remember to add this to your package.json file so your workspace can actually find it. So there's a schematics property in there that you will need to add, and then just point it to the path of the schematic that you have created to the collection.json file. So that will ensure that when you actually go and run your schematic command inside of your workspace, it will be able to find it. So from there, you will be able to rejoice. You have created a schematic. You are able to automate your life, and you can sit there and play, I don't know, what are all the kids playing now? What's that new game that just came out? Baldur's Gate? Yeah, is that it? Okay, I don't know. My husband's been sinking hours into it, and spend all that free time doing something like that. A couple of tips and tricks for effective schematic development. Again, I mentioned this, don't forget to build after making changes to your schematic. Schematics can also be chained. I don't know if anybody uses the tool NX, but they rely really heavily on Angular schematics and wrapping those schematics. So bear in mind, you can go and look, why write that code when you can just chain it and do what you want with it? So you can absolutely take advantage of what's already there. Let TypeScript be your guide. Again, not all of this is well documented, so don't be afraid to kind of use your editor to explore different interfaces, figure out different options and what you need there. And then finally, get comfortable with AST and visualization tools. I think it's a much better way to go than trying to regex for things. All right, this demo code, or the demo code I have for this project is available at, that is not, why is that so terrible looking? Sorry. Boop. Okay, now you can see it properly. Is available here. I've got a main branch that represents what our lives looked like before this upgrade. I've got a breaking changes branch that represent what it looks like when that library changed, and then I've got a magic schematics, I don't know, it's named something obvious, that shows the schematic applied and how that fixes everything. All right, so these slides are available here, tefedaiken.github.io/AngularMagicSchematics. So all of the content here today is available there. If you have any questions or anything like that, you can also email me, jennifer@batovi.com. Be happy to have you join our Discord. My Angular team is there to answer all sorts of questions. We've got great people in React. I'm all of front-end engineering, really, so.